Okay, so if I saw this question on a test, I would probably skip it and leave it for last. Number one, I generally just don't like the graph and chart questions to begin with. I find them very time consuming, but let's scroll here and oh boy, look at those answer choices. They are long, right? So that already throws me off. Passages can be long, it doesn't bother me, but when answer choices are long, I don't love it. So this might be one I would say for last, but let's take a look. It's not really a confusing question. Which choice most effectively uses data from the table to support Probst and colleagues' conclusion? So supporting the conclusion, I know there's going to be a sentence in here that just says what the conclusion is. So let's start with that. I don't bother really with this chart until I understand the passage. So it has been hypothesized that since birds can dissipate excess heat through their bills, bill size should increase with habitat temperature. It's probably going to be important, but we'll come back to it. To evaluate this hypothesis for a 2021 study, Probst and colleagues gathered data on mean bill surface area of species of North American thrashers, as well as on climate conditions of the birds' native habitats. Based on their data, Probst and colleagues concluded that the hypothesis was not fully supported. So this is doing something that we see in all sorts of SAT reading passages. They start off with one hypothesis, and then somewhere in the 3, 4, 5 sentences that the passage consists of, we completely erase what we just said, right? So this is why it's not worth your time to fully understand and support or summarize everything that you're reading in the passages. Just wait till you get to the meaty part. And here, right, we have to support their conclusion. Their conclusion, it says it, right? They concluded that the hypothesis was not fully supported. Now, yes, I am going to go back to that hypothesis, but I'm going to do it with this other new piece of information that I need to say the opposite of it, right? So what is it saying? The hypothesis itself is starting with as bill size increase, or sorry, as temperature increases, right? Then bill size should increase. So increase the bill, right? That is the hypothesis itself. However, it's not fully supported, meaning what we actually need to do is reverse this. So I want to say something like as temperature increases, maybe the bill size decreases, right? It could be that. It could be more that maybe there's no correlation at all. So that's another possibility, is that it's not about increasing or decreasing. It just could mean that there's no relationship at all. That might be representative. If I'm doing my arrows as my dumb summary, that might be representative as the increase in temp means nothing about the bill, right? So instead of the equal sign, I mean not equals, right? There's no relationship, right? So these two things, I know it's getting kind of crowded in here, but this is the kind of stuff I would write on my scratch paper. So that way now as I'm reading the answer choices, I'm trying to keep this general pattern in mind that I'm trying to look for in the choices. So let's see. I can look at the chart. We've got the different birds. The surface area, it seems to at least be increasing as we go down. That's convenient. And then the mean maximum temperature and the mean minimum temperature. So we just get some temperatures. I'm not going to try to interpret this. I don't know what they want to say. I let them say it themselves instead of me trying to guess what they're trying to say. Let the choices do the work, okay? So, although the Ben-Deer's thrasher has one of the smallest mean bill surface areas of the birds included in the table, its habitat has one of the lowest mean maximum temperatures in the warmest month and one of the lowest mean minimum temperatures in the coldest month. So, oh boy, okay, so what are they saying, right? This is a small or low temp and a small bill, right? That's what they're saying, right? Has one of the smallest bills and lowest temperature, right? So low temp, low bill. Well, that seems like the opposite of what I want to say, right? Because look at the things I drew in the box, right? I want to show that as the temperature increases, the bill size decreases. Another way of expressing that, right, is it's just an inverse relationship. It's two arrows going in opposite directions, right? So the increase or a decrease in the temperature should lead to lower bill size, right? But sorry, I flipped that. What we're trying to prove is maybe the opposite of what I wrote in this chart here, which would that be a lower temperature means a larger bill size, right? So if I'm going to flip the arrows, I got to flip both. What is tricky here is this choice A, which of course is going to be the first choice you read, supports the actual initial hypothesis that we were given at the beginning of this passage. So this is why you can't just go with the first thing that they tell you in these passages. We have to kind of undermine that. So we want the arrows to go in opposite directions, and choice A's arrows are going in the same direction. So even though both of those directions are down, as opposed to the original hypothesis, which both of them were up, it's still the same relationship. That is a positive correlation. We don't want that here. We want these things to go in opposite directions. Whatever the way it's presented, they need to be opposite directions. That's what I'm looking for. And so this fails. Notice I'm not checking the data here. It's not about the numbers. It's about, for me at least, the summary and the relationship and the pattern that I'm supposed to spot. So let's go to B. Although the cosmel thrasher has the second greatest mean bill surface area of the birds included in the tables, this is a big bill. Its habitat's mean temperature in the warmest month is significantly higher than that of the other birds' habitats. Okay, so this is also saying high temp. So again, this feels like the opposite of what I want, right? I mean, these arrows are going in the same direction and they're both going up. So this is almost exactly what we were told originally. Now, I also have some other problems with this. I mean, does it really matter if it's the higher than the other birds' habitats if I don't know anything about the other birds' bills? I guess I kind of do, because they're saying this is the second greatest mean bill surface area. So it's a big bill and it's a high temperature. So again, that does seem to suggest that this pattern is what the original hypothesis was, but not what Probst's conclusion was. So I feel pretty comfortable getting rid of this. C, and again, notice I'm not checking the data. I just don't like that process. I don't think it's efficient. Of the birds included in the table, the brown thrasher has the smallest mean bill surface area, so low bill, small bill, and the habitat with the lowest mean minimum temperature in the coldest month. Okay, so low temp. Okay, so again, this seems like the wrong direction. While the long-billed thrasher, so there's different thrashers, has the second largest mean bill surface area, so that is a big bill, with the second highest mean minimum temperature in the coldest month. So again, this is saying high temp. Again, both of these, they're talking about two different birds here, but both of them are going in the direction that we want them to go, right? So, or we don't want them to go. They're going in the direction that the initial hypothesis was going. So again, I feel like this is wrong. Now, I'm starting to get worried because it's possible that I'm supposed to be making some comparison with this one that I'm missing. So I'm starting to get worried. But this is saying a small bill is a low temp, right? I mean, I don't know. This is the point of a dumb summary, right? Let's look at D. Let's stuff our worries away and let's look at D and see what we got. Of the birds included in the table, the ocellated, I don't know how to, I guess that's how you say it. Ocellated thrasher has the largest mean bill surface area, high bill, and the habitat with the lowest mean maximum temperature in the warmest month. So this low temp, right? The lowest maximum temperature in the warmest month. I don't really care what month it is. Is it high temperature or is it a low temperature? That was the whole point of the hypothesis. So that seems like a nice little direction, right? They're going opposite directions there. While the Bendier's thrasher has the second smallest mean bill surface area and the habitat with the highest mean maximum temperature in the warmest month. Okay. Well, in terms of dumb summaries, this is really in two ways hitting the mark. This is exactly what I expected it to say. So I would pick this, and now what would happen next has a lot to do with how much time I have left on the clock and what module I'm in. If this is the first module, I've got more time. I'm going to do some more work. If this is the second module, I'm certainly going to pick this and move on because I might run out of time. And that's what this mark for review button is for, is not just do I want to come back to this with more time, but I also feel like I haven't fully proven this answer, because notice I never once looked at this chart, right? I never looked at the data. So I'm going purely on my dumb summary, but all the other choices were wrong according to what my dumb summary is. So unless my dumb summary is wrong, it's kind of got to be D. But this is the kind of thing that if I did have more time, I'd love to just get a little bit more confident, a little bit more evidence for my answer by now being able to back up these claims with data. So I'm looking at D, only D, and I'm going to see, does this make sense? Okay. So the ocellated thrasher has the largest mean bill surface area. Is that true? So ocellated thrasher, largest mean bill. Yes. So part one of that, yes. Check. And the habitat with the lowest mean maximum temperature in the warmest month. Okay. So warmest month, okay. The lowest mean maximum temperature. Yes. 27 is lower than all the other numbers. So check. While the Bendier's thrasher has the second smallest mean bill surface area. So Bendier is second smallest. Bendier, second smallest. Yep. Looks good. 198. So second smallest. Check. And the habitat with the highest mean maximum temperature in the warmest month. Highest mean maximum temperature in the warmest month. Yes, that's also true. 3657. So there you go. So it's factually true. It matches the relationship that I was hoping for. And so there we go. Now, if I were taking certainly a practice test, I'd remove that bookmark. I no longer am unsure of this answer, right? It's complicated. It's a hard question. There's no doubt that this took me a lot of time to solve, but I don't think I could have done it really any faster other than not talking to you out loud about it. But I also don't think that my process was in any way bad, right? I mean, they were very clear about what they wanted. It was very clear from the start what that hypothesis was supposed to be. I understood my task. My task was to undermine that hypothesis, to say that the hypothesis was not supported. So I found two different ways of showing that just by flipping the arrows. I understood what I was looking for in the choices. I found things in the wrong answers that kind of went against what I was expecting. And then in the right answer, it matched. And then the data matched as well. This is proof. This is what proof feels like. This is what most of my experience taking an SAT feels like, is I can prove these answers. And sometimes it takes a long time. I'm still talking after 11 minutes about this question, but it's to make a bigger point, which is some of you ask me, how can I be faster? There's no faster through this. And I don't think being faster is worth it. I think what it takes is maybe, yes, in a real test, this would take me 2, maybe 3 minutes to do. And I would be confident in that answer. And that might mean I have to make a sacrifice later on something else. Maybe there's another graph question that's just even harder, even weirder. And so that might mean I have to guess randomly on that one. But here, I have complete certainty in this answer. And D is the answer, just to be really clear. So I am right. But I would rather take that certainty. And I love this question, because even though it looks like it's going to be a nightmare, and it's long, the process of proving it is really just perfect. There's nothing really I could have done wrong except misread this or not pay attention to the fact that we need to undercut that initial hypothesis. So make sure you read those things and follow those instructions. And yeah, take the time. You can prove this. And none of this was hard to understand for me. So I would hope that you could be able to get to a place where on your SAT, something similar is happening. And that might mean taking a long time in a question like this. But if you can get the right answer definitively, I think it's worth it.